5 in the morning.
All right, sounds good. Good afternoon, Dallas. Everybody excited to be here? Woohoo! That was a great last talk. All right. So, in 1 second, my screen is not doing what I expect it to do. There we go. It doesn't want to stay. Okay, I will not extend my screen. We'll see if we get this work. All right, everybody. So my name is Erik Andersen. I am one of the co-organizers here for the Commit Your Code conference, and I highly recommend if you want to have positive mental health that you do not prepare a presentation for the same conference that you're helping organize. So it has been a journey, and I appreciate you all being here with us for the last few days. I want to talk a little bit about a journey that we had recently here at Yum Brands. Real quickly, I've been at Yum Brands for the last 4 years. I'm a senior software engineer there. I also volunteer in the community. I have my own podcast called Junior Jobs. Most of the work that I do in my free time is about helping developers find their first job in tech. I work primarily with Node and TypeScript, and about 2 years ago, we underwent a massive migration in Yum Brands to move from REST to GraphQL. That was my first exposure to the technology, and I wanted to share some of those lessons learned with you all. And you can find me on LinkedIn, you can find me on Twitter, X there. I am primarily on LinkedIn. That's where I do most of my advocacy work. And I will, to my deathbed, advocate that Bulbasaur was the premier starter Pokemon in the OG Pokemon universe. Who's with me? That's right, that's what I'm talking about. All right, so Yum Brands. Who's Yum Brands? Yum Brands is the largest restaurant company in the world. We are the owner of Pizza Hut, Taco Bell, KFC, and most recently, the Habit Burger, mostly a West Coast-based burger place, if you're familiar with that. Yes, awesome. So historically, despite the size and the scale that Yum was operating at, we were not able to leverage really any of the operational efficiencies or customer insight benefits that you think a large company would be able to operate with because we were working in technology silos. We had a lot of redundancy, even though a customer is a customer, a cart is a cart, an order is an order. We were duplicating that across all of our major brands. We didn't have a unique way or a consistent way to tie customer data since we had different identifiers and different brands required maybe a phone number, maybe an email, et cetera. So we weren't able to understand kind of patterns of our customers either. So starting about 4 years ago, we were tasked to create one e-commerce platform to rule them all. And we successfully did so. In about a 6-month period, we were able to completely onboard KFC onto our own custom-built in-house solution. The goal being that brands would still operate, or they would still control the front-end experience, whereas Yum, as the parent company, would own the back-end experience. We did it successfully in just 6 months, and we won. But at what cost, right? And the pain points that we were experiencing from there was the result of a lot of decisions that we made early on where we were optimizing for speed of delivery versus maintainability of our platform, I would argue. So, for example, we took a microservice REST-based approach, primarily because at the scale that we're at now, and I'm looking at some other Yum folks in the audience, I think last I heard we had 2,000 people across the program. It's developers, product owners, analysts, managers, et cetera. And so obviously we couldn't have a monolith. Just imagine the merge requests and the conflicts that we would have at that scale, right? So we needed a microservice architecture to keep this in control. So originally, that REST approach meant that we had teams built around business domains, users, carts, products. But the problem that we saw with this approach is that it led to very interdependent microservices where we could either have on the back end For example, if we wanted to hydrate a cart, that would be, 3 or 4 API calls. One on the back end to get the cart. That cart would have to call in to get the store menu, and then it would have to call and get product details for each store to be able to return a fully fleshed cart object. So now we have this independency of web services. Or we could have done that on the front end, right? But still, those would have been sequential API calls for the front end to call to maybe get the cart. Maybe that's just a list of IDs they get in the response, and then have to make subsequent calls to a product API to get details. Heaven forbid you have different offers or promotions on that cart, and now you're making even more calls. So during that, to solve that inefficiency there, we did some research and identified GraphQL as a potential solution. And over the last 2 years, as we've been now rewriting the rewrite that we did, it has opened up so many new opportunities that I wasn't aware of before. So that's part of the reason why I was so passionate and want to talk about it today. So the way that GraphQL works here and solves that particular problem is that you instead have a GraphQL router that is responsible for stitching together the details of a single incoming API call. So from the client perspective, a single HTTP call to a Graph API, while it may be requesting the cart and the products in the cart and the inventory levels for each product in that cart, while those may be operated by 3 separate web services, it's stitched together, and that magic is handled to you by the GraphQL router. So you still get the benefit of the client not having to make all those calls, whereas you get that streamlined, independent, siloed architecture from our backend teams. So other pain points that we had. So this is just a screenshot of what documentation governance might look like in a REST world, where you have to manually document the schema of your API. And since that is managed separately, what does that usually mean? That usually means that, it gets out of sync rather quickly. If developers hate one thing, it's documentation. So the beauty here about GraphQL is that the types that you are writing is part of your code base, and it is interpreted by that router and enforces that schema for you. So there's no 2 separate documentation repos, code repo that you have to manage, so you're guaranteed they won't get out of sync. And then it also helps enforce standards, because that was the other problem with a program of 2,000 developers and only a handful of enterprise architects to help orchestrate that effort. It was very easy for each team to go off and adopt their own naming standards. So we would have issues where we would have its customer ID in a snake case. One team would reference it like that. Another team would use camel case for the customer ID. Some other teams would call it user ID. And as the Yum e-commerce platform powering all these different brands, we wanted to have a consistent voice, a consistent product, a consistent representation of what a customer might look like or a product might look like. And the REST approach meant that it was so disparate that it didn't have the polish that we wanted to have. And then lastly here, if you think of the idea of fetching more than you should, the overfetching problem that REST traditionally has, from a performance perspective, there are 2 issues that we ran into. And that is when you're trying to onboard a smaller market, like KFC Kuwait or something, maybe the network structure in that country may not be that optimal. You want to make sure that you're minimizing as much network traffic as possible. So the front end can specify the specific fields that they're looking for, as opposed to in the REST world where you make one request to get a cart, maybe you get 100 line items back, each cart object being 20 lines long, you're getting the SKU of it, et cetera. You may not need that. So why are we burdening the network traffic with that extra network load? And then similarly, from trying to evolve your API perspective, if I wanted to version or release a breaking change in a REST API world, now I have to introduce essentially a new API, right? So in the path to your resource, you're saying, Yum e-commerce API /v2 slash, blah, blah, blah. Now you have to maintain the v1 of your API and the v2 of your API at the same time. Whereas GraphQL, since you know specifically what fields are being requested, you can know when it's safe to completely delete fields on your existing API or add new ones, because you know you're not going to be affecting any existing consumers. And GraphQL itself, or Apollo specifically, their implementation of GraphQL, provides a lot of tooling around that for you, so you can have more mature governance around the evolution of your API. All right, so GraphQL, I showed some screenshots earlier, but essentially, people say it's like SQL for your API. That's not entirely true. It's not exactly like SQL, but essentially you can describe your data, and then you can skip specifically what you want, and then you can iterate on that even as your service evolves. So anyway, I've talked enough about it. We don't have too much time here. So I want to get in and show a little bit what that might look like. All right. All right, so for purposes of this demonstration, we have one example retail supergraph API here that I've prepared for this. So typically when you're deploying a graph API, let me make this bigger for you. You have your router as a separate deployable that does that stitching together. And then each subgraph or microservice is going to be its own deployable under that. But for this demonstration, to keep things simple, I've wrapped that all into this one code base here. So you'll see, for example, the way that this is structured. The router has a specific configuration. It's listening on port 4000. There's some instrumentation details there. And then it is just going to say, hey, forward all headers here. And then I have a schema definition here defining where the router can find the definitions for each of my different microservices. You can see they're named, checkout, discovery, inventory, etc. And it includes the location of where it can find that deployed API, as well as where is the schema defined. So each one of these routes, these could be deployed on different ports, on different machines, but since they're all running locally, that all looks the same here. And you see references to these schema files. So now going into the subgraphs here, I have one for each of these different domains listed. Now I'll open up product here, for example. So in the microservice itself, you define that schema. Let's pull that up. And you define, okay, if my API is being queried by this query, list all products, search products, this is the type that it will be returned. And then you can define what that type looks like. There's an ID field. This exclamation mark means that I promise you it will be there. And then you can define other things called a mutation, which is if you wanted to change that. So you can see descriptions here, just basic, type, ID, product, just like you would expect, like maybe like a TypeScript file might look like. And then, so the resolver here. So the router receives that schema. It now knows how it is allowed to query you and for what types of data. So you saw in that schema file, let me pull that side by side. We have our queries here, list all products here. I'm defining that schema. Then I have the implementation here under that query type. And then I'm going to return some products. Now a product, pause here for a second while it works itself out. So for purposes of this demo, we'll work through it. Maybe it'll work itself out. I have just importing some JSON data, just an array of products from this local data.js file. But this, you can think of this like a database or another API call that you need to make. So then when that product gets returned, is that annoying for you guys? Is that hard to hear? Let me switch microphones. Testing 1, 2. Even worse. Testing 1, 2, 3. I'm going to do my best to yell. I am typically a quiet and reserved human being, so I will do my best for you. And maybe turn down the volume on the stream too, if I'm now yelling into that mic. Okay, so if I look at the definition of that product now, so I'm saying when that product is returned, sure, I have this data that I'm pulling in from that JSON file, but then I can also specify on a field by field basis how I want that data to be resolved. By resolved, I mean how it's going to be returned. So this ID, UPC title, like that, this data for my product might be coming from my database, but I can have certain calculated fields. Maybe this variance call, if this is also requested, then maybe that's another table I need to query. Well, if my products are being requested, nobody cares about the variance, I don't have to make that extra SQL call. So my service is now that much faster because it has to aggregate that much less data. All right, and then so subgraph, okay, and this is the last configuration. All this file is doing is just saying to my subgraph, in my local structure here, this is where my schema file is. That's essentially it. So I'm going to go ahead and run this locally, and we're going to pray that the demo gods are with me. All right, so now I have all of those subgraphs running on my machine. All it did is just go through an array of all these different configurations and launch them on my machine. Now I'm going to go run that router. It's going to stitch it all together. Okay, so my router is on port 4000, but if you remember from earlier, the subgraphs are on port 4001. So now if I come in here, all right, so the router, so not only does that stitching together, but it provides this postman-like experience and management admin experience. Now I'm going to do that call that I talked about earlier, where I'm querying a user's cart. And this in a REST world would be, I'd have a REST microservice, a cart microservice, and a product, and maybe a variant microservice. This is one call, my front end, I'm simulating calling to my back end. And we'll see that it's one API call response back, even though that was sourced from 4 different microservices. And so the additional benefit here, I can remove that username field there, and now in that response, that's not coming back either. Or we talked earlier about how variance might be an extra database call. Well, maybe I don't need that for the screen that I'm showing on the front end. And now that product variant information is not coming back. And not only does it provide like this a postman-like experience, but also provides this automatic documentation for the consuming application, where I can now see here, these are all my available queries. I'm querying my user, I'm querying products. I can click in there. Oh, it expects an argument. So it's populating that down here for me. And I can specify, let me do an example query, new query here. And it specifies, it creates the structure of the request for me, so I don't have to go through and construct that all myself. So it makes discoverability of your API that much easier. So here's some more documentation. If I wanted to understand the exact types that are supported by my schema, I can come in here and I can see the different, the cart object coming back, the product object, once again, easy for discoverability. We talked about governance a little bit earlier. It also provides you essentially a GitHub-like experience where you can see the evolution of your API over time. Where before, each of our REST services were managed separately, now that we have this router here and this single location, it can manage the history of your API. So you can see how it's evolved over time, and you can just similarly revert changes to your schema if there is a client having an issue. And then checks here as well. So I'm going to run this locally to show what that might look like. So now imagine you are an enterprise architect and you are stressed out by all of these stupid developers who are making all these breaking changes to your schema. So now if I were to go into, let's say, let's do that user query again. I'm going to go to that schema file. And here I have a list of all of the fields that I'm saying I promise are going to be returned. Well, maybe historically I used to let people sign up and they had to create a username. So it has to be there. That's why I have the exclamation mark. Well, let's say now I want to support a social login. So username may not be there anymore. So me, as a silly little developer, I might say, okay, I'm going to mark that as nullable. So now I could easily put in my pipeline a command like this, where I am saying, hey, check the user schema. And it is going to go and compare my local changes. npm run, check schema users, other way around. Okay. Can I find so? Let me figure that out. So it should look locally if I have it configured correctly. And it's going to compare my schema change locally to what I'm proposing gets published to my example here. And you can see, hey, there's a field change. It used to be a non-nullable type. Now you change that type. So now before your code gets merged in, you have that automatic check to make sure that you're not introducing a breaking change. All right, we are getting close to time. There's a lot more that I wanted to show you, but that's it in general. So if you are in a place where maybe your team is growing larger than you initially had, you want to introduce some extra checks to make sure that your system is stable, and you want to have you want to productize your API to make it consistent across multiple teams, then I would suggest that GraphQL is the way to go. Thank you.